Good evening once again, everyone. And welcome to session 10 of our faculty development program on next generation electronics and communication systems empowered by ML and AI, sponsored by ACT Atal. For the session 10, we have Mr. Sandeep. Mr. Sandeep, to you.
Yeah, Pankaj, I can hear you.
Okay, thank you. Before we start, let me give you a very brief intro about our speaker. So, Mr. Sandeep Kumar is a seasoned software architect and engineer with over 20 years of experience in enterprise application design and development. At TCS, he currently leads AI and machine learning driven initiatives to optimize large scale network simulations and operational efficiency. Previously, at Dairyland Power Cooperative, he superheaded the digital transformation of energy systems, developing machine learning models for energy demand and renewable generation prediction that delivered significant operational savings. He also BTech in computer science and certifications in applied machine learning from Columbia University and Microsoft Azure Fundamentals, recognized with multiple honors including People Power Dairyland and Sport Bravo and Project Star Awards. Sandeep is known for his hands-on technical leadership. His passion lies in bridging AI with real-world engineering challenges, driving innovation across energy, logistics, and financial technology sectors. He combines deep technical acumen with strategic foresight to deliver intelligent and data-driven solutions with measurable business impact. With this brief profile, I welcome Mr. Sandeep to our faculty development program. I also request the participants to please interact with the experts so that we as an academician could have a glimpse like how AI is revolutionizing the industry. So now I hand over the session to you, Mr. Sandeep. Okay, one thing more. He's in TCS US. So I think there should be a morning time there.
Yeah, it is morning here.
Okay. Then
Yeah.
I should say good morning to you.
It's fine. Good evening,
Okay, anyways,
everybody.
I hand over the session to you. You please, you can share your screen and then continue.
Sure. Okay. Thank you, Pankaj, for having me and giving me opportunity to share my experience. I really appreciate about it. Okay. Let me see. Give me a moment. It's not
Not
giving
an
me
issue. Please
permission.
take your time.
Yeah. So seems like I need to get out and get in to share the content because in Mac it's not allowing me to share the content because first time I downloaded this
Actually,
WebEx
we
here.
don't have any idea about Mac. We are using Windows only.
No,
So
it's
actually,
fine.
there might be a window. There might be a tab in the bottom. Share.
No, it's there. But Mac says like it need to give additional permission to start sharing.
Not an
So
issue.
I need to, yeah, I will come out and come in here.
Okay,
Okay.
not an issue.
Give me a moment. Past almost 20 years, but I have been working in the machine learning and AI sector almost 6 years now. I started in 2019 when I was working in the Dairyland Power. So the how I got introduced to the AI is means Dairyland Power. Let me tell you how my experience in the Dairyland Power and how the energy sector work here in US. Uh, so there are two sector I will cover here where I have worked in past 6 years in and using the machine learning there, the energy sector and logistics sector. Energy is like a power. It's like a daylight power where we generate the power and we transmit the power to the distribution centers. And logistic is UPS. UPS is the one of the biggest logistic company in the, I would say, in entire world. So we deliver almost 80 to 90% of package every day, mostly in America and North America and Europe. Uh, so these are the two sectors I will cover, and I have experience and implemented the solution on those two industries. And this is just a small intro. I think Pankaj has already given better than this. Okay. The roadmap, I will go through this almost 1.5 hours. We already have like a 12 minutes already gone. Like introduction and then energy demand prediction and solar generation forecasting, wind energy prediction, and combined energy optimization, and in UPS, how we are using AI, agentic AI system in my current engagement, and then lesson learned and trends. Uh, this is going to be the agenda. Okay. So first thing, the AI thing, ML and AI, what is basically, it's kind of disrupting the industry as of now, and everybody in the engineering side, especially starting from the computer science, it's being like a in past couple of year now, it's getting worse and worse, and people is getting too much anxiety about it. What's going on? How we can do it? Will we survive in this environment or not? uh, I would say, as long as we it always happen, like in it's always like when the .NET .com the technology transformation happen in um, the same thing happened that time when the computer revolution happened. The same thing happened that time as well. As long as we are continuous learning and having the business knowledge, marrying these two together, we always be ready for the market, and market will be always need the engineers who have the current technical knowledge and and have the business knowledge. In the AI, what are the things matter more? Like a data is the most important thing, and like I think, and it has been said by the Narendra Modi as well. Data is a new fuel for the industry, and that's a very valid statement. And putting any solution, when we have any problem, putting that solution at a scale level, that's matter to the industry all the time. Because small solution, anybody can develop. When we are developing for industry, it have to be scalable, and we need to solve the problem at the complex level, and where like a uh, yeah, I have developed like I would say hundreds of POC, and I would say at least 10% of the rate is the I was able to put that in the production, and it that mean POC is good. You learn it and you prove that out industry how the technology or the solution work. But until we put that in the production ready environment, it doesn't help to the industry or to the anybody. So that's high level, I would say, from the technology side. Let me go to the next level. Okay, so I would go one by one use case. I have four use cases where I have implemented the AI, and we have seen the really benefit what that bring to the industry, and especially in these two sector where I have worked in. So first use case is energy demand forecasting. Okay, so what is energy demand forecasting is? So it's when we implement the solution, it looks easy, but initially, like how the energy sector work here in US, it's very different than India. Uh, the in US, like we have regions like in India we have north, west, south, and east. So like same we have different regions here, and based on the region, like each region, all the power generation companies, they generate the power and they add to the pool. And uh, how much energy they generate 100 megawatt, they generate the 100 megawatt, add to the pool like a common pool, and then take the power from there. uh, this is the real the energy transmission. That's how they have, and all the like a common big transmission lines are common. Like anybody can put their energy there, and then they can take out wherever they want. That's a one part, but second part is it's not just like a putting energy there and just taking out. It's a kind of a stock market where we price varies. Like how it doesn't it doesn't work like we put 100 megawatt and we take 100 megawatt and it's same price. No, we are adding the energy to the common pool on a specific price, and when we take the price of selling price of the energy. So the problem statement was like if we can predict how much energy we want in next today, next tomorrow, or maybe if we have the like a longer plan is more better, right? So if we know how much energy we need on that day, we can bid it on cheaper price on the as early as we can. So that was like the prediction of how much energy we will be needing during maybe tomorrow or maybe their event or maybe something. It was very manual process. Very manual means like how the like a planning people was doing. They were putting all the data in Excel, and they have created quite a bit of Excel formula to predict based on the average and all, seeing how much energy they will be needing. So that way they were doing, and they were doing it in past, I think more than 50 or 60 year, because their company is older, like over 100-year old. Okay. So when I see that I was talking to them and they explained like in cafeteria, actually they were talking about yesterday we lose quite bit of money on that. Then I talked to that in department and just I understand their problem and propose the solution. I will say why we can't use the machine learning to learn and the pattern and predict the energy demand for us. And they say it's a good idea, let's do it. Then that's one part. Okay, so the main part is start how we implement. What are the data point we need to pull? So to do that, we were looking like how much data we have to train our model, and from where all different source can make impact on the demand, uh, and pulling the data from those different sources and doing the data engineering on it, cleaning. So these part, like some of the data I put it here. Like we took all 15 years of historical uses from our area where we serve the energy, and we take the data points at hyperscale. The basically the weather is the most important factor here in USA in energy uses. So in cold or any any hot, when there is a summer, and uh, any like a cold winter, like when we having it was in Wisconsin, so we have like a very cold weather there. So based on that, like every year, every day is can be different energy uses and local events. So in America, like people do lot of eventing, like a big sporting event, big like a concert and all. Like they go by each small cities and even towns, they have that. And that drive lot of like energy uses. And if we have like a couple of event is coming, and on that weekend, and a couple of sporting event is going on, so we had to bring like a lot of energy we had to buy. So if we are not planning, then we have to buy extra, and we have to pay very heavy price of that energy. So that was the first solution we put it here. We develop our machine learning solution, and we develop our model trained with we tried all different algorithm, but eventually we found a neural network uh, help us and to give us the better prediction. And we were able to predict 94.6% of accuracy. It was better than our MISO, if you can see here, the MISO energy, that's the like a common pool. They also do the prediction, and we were beating them like a 10% of accuracy. And that's a huge win. We bring the company almost, we save $70,000 per month. And that was a very good initiative, and able to save like a quite bit of money over the years. Any questions so far on this huge case?
Uh, I want to know something like which year you did this?
This we start in 2019, and we deliver in 2020.
Okay, so your company, the company with which you were working, it was actually like it was producing energy, or it was purchasing from, or only a
E-
distributing company?
No, it is GNT. Here is the GNT is generation and transmission. So
Okay.
we generate and transmit to the distribution center. Distribution center means like each city have a different distribution center, and each farmers doesn't come under the distribution center. We directly deliver to all the farmers, all the big companies. We directly deliver. So that's how it was.
Okay, Mr. Sandeep, we have one question in the chat box. If you can check it out.
Can you read it out? I
Yeah,
don't know
yeah,
where it is
definitely,
chat.
definitely, not an issue. There is one question from Hari Kumar Naidu. Generating company, transmission company, distributing company, trading is implemented across the nation. Wind is highly unpredictable. Then whether are you forecasting based on historical data using what technique? The question is, I think, what is the exact question? They are asking about the wind. Like wind is highly unpredictable. Then how you are forecasting?
Yes. So here is the weather. Okay. I in compared to, means, I when I was in India, I never see such a bad weather, and such a like a unpredictable weather there than here. Here is weather is really unpredictable, and but the good thing here is lot of companies have invested heavily to do this prediction of weather, and they are doing really pretty good job. And in the predicting of the weather, like how much wind going to be, how much rain going to be, how much bad it going to be. Even they send the alerts like if it's going to be too hot, too cold, or too much windy, or tornado is coming, or hurricane is coming. All these I won't say they are 100% accurate, but they are pretty good, pretty good. And we did not had all the data. We buy all the data. We connect all these different companies, and we ask them like, this is our requirement. We need to purchase like a last 15 year of data on all these local locations, not just like city, like even we give them the like because here are the farmers are big, so we had to give them like individual locations, their coordinates, like we need the data from this coordinate.
Okay, so these companies are maintaining last 15-year data.
They are maintaining hundreds of year data, I would say.
Okay, cool.
Yeah, these companies, the weather companies, and even you can say sometime you don't have to buy, because we had to go very hyper scale. We had to buy.
Right.
They in the national weather. There is a website of I forgot the name. The government also maintain the data since the like I don't know, like 70s or 60s. They have the all the data, every hour data. And if and initially we thought we will go by every 15 minutes, but it was too much data. Yeah, so we went for every hourly data.
Okay. Cool. Thanks for answering the
Yeah,
question.
but these all the data are publicly available from the government site. But if we want to go very detailed and very hyperscale, then we need to means we can reach out to different companies and get it. But just for the educational purpose, these all the data are coming available on the government sites.
Okay, fine.
Yeah.
Thank you.
Any other question so far?
I think there's the same question. The question from the same person. 20-minute wind data is available.
Available every minute, I would say, from the private companies.
Okay,
They change the prediction.
if we want it for study purpose, then
Then study purpose is hourly.
hourly.
Yes,
Okay,
yes.
that is from the government's
So
websites, right?
yeah, so
So,
here there are companies, they're private company, they charge very heavily. They have sensor across the country, and they produce the data. They have IoT sensors across the across the company, every country here in USA.
okay.
And they collect the data. They can give the data as you want, like every coordinate they can give the data. And every even the data is being generated for them for every second. But they summarize that like every 10 minute is the minimum, and that's what they give to us. And but they have the data.
Okay, fine.
Hello,
Yeah.
hello.
Yes, yes,
Yes.
Hari
See,
Kumar.
this willable distribution is done based on the density, actually, of the velocity of the wind every 20 minutes. That's what I know. And these data are standardized all over the world. And on that basis only they predict the wind, as far as I know. And this is based on density of the velocity. So for the whole year they take, and then they predict. Are you doing this?
No, we are not predicting the wind. We are just getting the data, hourly data from the all these private companies. We are not predicting the how much
So
wind
how can
going
you
to be.
assess that whatever you are predicting is right? You know, how much error is there? Have you calculated any error or any time, whether it works absolutely okay all the time?
No, it does not. And that's what like we had 94% accuracy in our model. Like
So
we
6%
there is
error is there.
yeah, there are 4 point, I think 5.4% of error all the time. And sometimes it's even
See,
higher, but it's
Melbourne in Australia has got
uh-huh.
unpredictable weather. See, it will be raining right now, and then there will be, you know, clouds all over. Wind will start blowing, sun will be there. So all
Yep,
sorts
yep.
of weather is there in one day in that city. So whether it is the same phenomena in US,
It is. I think I never been Australia, but I would say it's maybe bad than Australia. Here is weather is very unpredictable, very unpredictable, and in
so the accuracy
coastal
will
areas
be,
is even bad, more bad.
so it is only guess. We can't predict
Yeah,
100%, correct?
yes, but like I would say those company and their models to predicting they're doing very good job. But it's weather is weather. Like things can change, but they are like not like they are completely guessing. But I would say we have
Yeah,
seen.
near about we know what will happen. Yeah. Okay.
Yeah,
Yes. Yes.
yeah.
Okay. Thank you.
So,
Thank
and
you. Thank you.
the reason why the because we have seen that as you said, like weather change here every hour, every 15 minute, every 20 minute, sometime change,
Yeah.
but
Every
every hour
20 minutes.
definitely it change. So what we have done
Yeah.
here, initially when we put this solution, energy demand forecasting, it's once a day. So every day it do the two prediction. So today
Okay.
and rest of the week. the
Yeah. Thank you. Thank
but
you.
that was, yeah, that was not helping much because when our market people, they
Yeah.
look into that and things change, then we had to do that every hour
So are you
we
doing
pull
forecasting based on short time or long time?
both. There
Forecasting
are
for short time or long time?
there are two. One is short time is today, and the long time is for a week.
Okay. Okay. Thank you. Thank
Yeah, we more than a week was not very good prediction, so
you. I just wanted
we
to
did.
know. Yeah.
Yeah,
Nothing else, actually. Okay.
yeah.
Thank you.
No, it's a good question. It's a good question, and thank you for having the conversation, because just saying talking on the presenting it doesn't help much.
No, thank you. Thank you. Thank you very much.
Yeah.
Thank
Okay. Let me go to the next slide. Any further question? Can I move to the next slide? Okay.
Yes, sir.
So
Please
here
go
is
ahead.
sure. Here the architecture what we have used, like we collect the data from all different places, and then we do the ETL pipelining. These are like a standard process. I think here we have all the education people. You guys know more than what we do. And then did the feature engineering, find out what are the like a features really make a difference and we really need in our model, and then design the model and then deploy. And putting that in production, we were using the Azure. We put that our model in Azure. Okay, so I think that's just a technical part. The another use case we took after that, because there are two part. One is the like a demand generation, demand forecasting. Then second use case we took on the solar generation. We had all four type of generation, like solar, wind, and thermal, and the what the fourth one we had. We have gas as well. Yeah. And natural gas also we have a power generation from that too. Okay, so uh, the the way how those operate, mostly the thermal power, they operate based on the demand. Again, same thing. Like if we see like our weather is good and we were able to produce enough energy from our solar and or our wind farm. We don't have to operate our thermal power as a higher capacity. So we can schedule the operation and basically we can schedule our operation and save some money. Or maybe if the weather is not good, maybe too much cold or not windy, so we won't be able to generate, then we have to generate higher energy from there. So we need to engage all the resources, shifts, and deliver from there. So to to get the data again, like either because we developed the first model and able to prove that out, like our model worked good, and now we were able to start the another project from the solar side. Here is again we had the data as we collected from the weather, and but in this case we collected from the all our thermal sorry, or our solar farms. So how the weather is there, and based on that like operational data also we had to marry with them, like how many solar plates are going good, and if they are in maintenance, and we put them in offline. So all these data like do the like impact on the our model training. Uh, that's and that's another thing, like we were able to in this case we were our accuracy was 89%, and backup reduction like 15%. So we were able to like almost save 15% of like a thermal power operation just by doing the good prediction on this use case. Any question on this use case? Okay, so let me go
I
to
think
the
there's no
next.
question. Please go ahead.
Sure.
What is
Third,
the efficiency of solar panel? What is the
you know,
efficiency?
yeah, they really get bad in the winter, but sometime we have seen like they get degraded, and that's we had to that was the main reason we had to put the operational data of their maintenance. So they get degraded and randomly actually. So that's what we have seen, and but the operation team was working with the vendor, like why that is happening. And sometime like even like we get too much snow, and those solar panel get covered completely and doesn't come out until the like a couple of days of sun. So these are the thing happen. And then like tornadoes and those if any like really bad weather happen, tornado happen, and it's throughout all the solar panel.
Mhm.
So that's these are the like a little I would say small details we had to put in place when we are doing a JIP production system. Like normally we just do we just collect the data like weather data and location, and we just do the prediction, but that doesn't help to the actual operation. So we had to do all sorts of data we need to pull, which can make the difference.
Thank you. Thank you.
Yeah. Okay. And same for the wind. And like for the wind, the thing what make really the surprise to us, we always was thinking like the wind, if like all the wind farm, like our wind turbine, they work with the wind only. But we have seen when we were talking with the operational guy, like how they work, and we get to know like they are big, very gigantic, and like as a technical team in the IT side, we never get interaction with any uh, like a operational team. We never know
See,
that, but yeah,
actually, wind
yeah,
turbine is never stopped. That is what is the latest code. They say 15% voltage if it has come down, okay,
yeah.
then only it should stop. Otherwise, it should keep on running. That is known as low voltage ride through. So wind turbine is always running. Thermal power
Mhm.
station is also always running because
Always
starting is a
running.
problem. So
Yes,
these
you
two are
cannot.
always running.
Exactly. If it goes down, it's very expensive to bring that up.
Very
And
expensive. Yes.
yeah, and for the wind, the surprising thing to us, Harisa, the like when there was no wind at all means at all,
Yeah.
completely. But the winds we have seen, like a wind turbine is still moving. So
Yeah. It
the
is there.
region
It is
was,
that is a code now. That is a code all
yeah,
over. It
so
should run.
yeah, means why it was running actually because of the heat. So the in the like a summer, especially when the soil temperature go higher,
Yeah.
it generate the like fumes, and then it make the turbine moves actually. So that was very surprising. Like there was no wind, but the wind turbine was moving, keep moving. So so these are the like a little things, and very important thing we get to know, like when we really want to implement any solution and we want to learn about that huge case, go in deep and talk to those operational people, what is their problem, and what are the additional factors which make the difference here.
Yes. Thank you, sir. Thank you.
Yeah. This was again basically the forecasting model, and that again help like on the wind farm side, how much we are generating, and by putting all three together, we were able to really make big difference. So we were forecasting the demand, we were predicting the solar and wind generation, and based on that, we were optimizing our thermal operation, and we were able to save quite a bit of money on that. So when we put all different solution together, it make big difference. Uh, So these are the three use cases from the energy side which I have implemented. Any question on this side? Then I will move to the logistic side. No. Okay, so those were especially ML models. I mean, there was no automation. There was just a like a developing a model and training and developing the model and deploying and putting that at scale. They can be huge, and the continuous training, that was we were doing on these all three model here. Like every week a new data came, and we collect once the like a 4 cycle happen of the data collection, and then every month, then we do the one more. Every month we retrain the model. That's what we have done here. Okay, continuously training, and that, because things change, and let's more model continue learning from there. But in the current use case, I'm not working on ML anymore here in the current industry, current my engagement. We are leveraging on the existing models, especially the LLM. Now we are using the Google Gemini Vertex, uh, and so here how in my area, what we are doing here is uh, in UPS, we basically in any I think in any of the logistic company, the how the operation work is they do the they again do the planning, like how many trucks or any aeroplane or maybe how many delivery vehicles we will be needing for next month, and if there is an event happening, how we will be managing that event. Like just an example, if Apple is releasing a new iPhone, it's a very different use case. So it it's a unique use case, but it's not just Apple. Means I mean to say this type of event is very unique. So we had to keep we had to plan accordingly, or all the operation in a manner like we when the demand will hit, or like unexpected demand will hit, we are able to deliver that. And to do all those things, the planning part, we have developed a simulation. Basically, we have a simulator that's a very gigantic monolith app, and what it does, it take uh, previous demand. We can push any demand for 1 month or 10 month, or based on our simulation. Basically, in the planner, if they want to see how it was happening entire year and how we are going to be in next year entire year, so that's a different planning. So based on that, their date range, the different simulation happen. So what this simulation do, it take a whole entire historical package, and the smalls, bags, bigs, on all different type of packet, and and route through them in the network. Network is from each node to each node, like all the destination point and all the origin point in the entire country in the US. It's a really, really huge system which do this simulation. You can see here the our individual servers capacity. We are running like a some of the servers we have 1 TB, 2 TB, 3 TB of the RAM, and they sometime run our capacity, and we had to add more RAM. So it's and by using that much, and we I think I did okay, I didn't have the UPS, but it take almost 1 to 2 hour of simulation with that big machine, and then come up with the result, like here going to be the next plan for whatever change we made. Just an example, like if we take the demand from previous like a 1 month, and we want to predict for next month, and we need, but we can just not predict right away. We will make the changes according what is the next month is going to be. Next month is going to be like some holidays, some maybe one of the area is impacted with the like a hurricane. So we and maybe some of our delivery center are not operating on those days, or maybe they have the cancel and replace, or maybe they are canceled the operation due to different region, maybe planned or unplanned. So all those data we push, and then we do the simulation. This whole process is very combustion, and it take quite a bit of effort from the planner side. And if anything fails, they had to repeat this whole thing again, and it's very time consuming system. So what we have, right now it's the our the engagement going on. We already have put quite a bit of agents in place, the AI agents in place. So the whole thing what we are developing like this multi-agent system, and what it doing it are all the agents, the AI agents is working alongside with the simulator and trying to check the health, and the data is flowing through. Is there anything it need to change, or it need to stop, or make a pause and make some adjustment, and then continue from there to simplify the life of the planners. And here we have, as of now, we have one our main agent which do the whole orchestration of which agent it need to call based on the like a the situation. It's not like predefined workflow. It's just AI is making, we are pushing all the data to the AI, and AI is making decision what to do next here. And it's right now, because we are in the initial phase, it's not as fully mature. We in each step where it's trying to make any like a pulling data, we don't have any we are not giving any like a restriction on the pulling data, because we are keeping the data in our area. And but any operation its agent is making, like any modification in the network, modification in any calendar or operation, we are always keeping the human in loop. So that way, the planner is when the agent is working, it keep notifying the planner. Can I do that? I have seen this problem here, and if you are okay, here are the change I'm going to make, and it's making those changes. If it says yes, if it say no, then it say like okay, then if you want to make the change yourself, please make those change and let me know, and then I will continue from there. So that's how the new version of AI I'm seeing, because we had couple of different teams who is working on the developing our own models, but the agentic AI is the AI which will change almost every software what we have right now. Try to simplify them, or try to no, or try to like basically use them to simplify the life of the user. So that's how we are seeing the industry is having a big challenge right now. Oh, because when the hive is come, people think like, oh, what to do here? Okay, everybody talking AI, and we how we can use the AI, but people don't have the proper use cases, proper analysis, and that's why people get stuck in a place, like they started something and they are not able to complete. In that one, like all the technical architect, what we are doing here, like we have one, as I was explaining, our orchestrator agent, which do all the routing, managing the life cycle of any request, and coordinating with all the other different agents. Uh, and we are because the we had our whole team, and all area where I work is they are the Java soft. We all our engineers are Java background, so that's what we are using is Spring AI as a framework. We could have used the Python, and there are a lot of good framework in the Python, but due to the resource limitation we are using, and we are able to complete our use case using this. So we haven't seen any big difference. Any questions so far? Okay, so I think the outcome what we are seeing already here is quite a bit of faster turnover from the planner side, and reducing the load from support. So any issue happen, let me go back into our agentic system. If there is any issue happen in the simulation run and it failed due to loading different lot of data, maybe data didn't come well, or maybe there is an issue or something, or unknown issues, they always have planner is a business people, right? So they don't know technical, so they have to reach out to support and wait for them their help, and support team jump in, and then they look into the and they fix it, and then they let the planner know by the time like whole day is gone, and they lose a lot of time. So that's the saving we are bringing here, like a very fast turnover from the planner side, and to doing any planning, and from the support side is a big reduction for small thing, which can be AI can be solved, or can be like a help there. We are and those are the major thing actually. That's what, like a little things is taking longer time, and we were able to reduce over 60% of their number of tickets which is coming here. And right now we are running like a 12 agents, and the agents it's like a overgrowing now. So we are every other month we team is coming with different ideas, and we are bringing more and more agents, AI agents in our AI farm. Any question?
What about the power dissipation, sir?
Power dissipation means I did not get it.
Like, like if any, suppose we make a system like this.
Uh-huh.
So what amount of power, is there any variation like earlier developed system, like a simulator is there, any kind of
Mhm,
journal simulator, suppose we have.
mhm.
So how it is different, this AI based? So what about the power? Is there any differences power dissipation like of the whole system?
Power
Like
means energy.
it consume energy, it consume less or no, more?
Oh, okay. So in our case, because we for us we haven't checked that, because for us in this case our simulator is very expensive and very heavy. They are already always running. Okay, so they are always running, and we uh, honestly, we haven't looked into the power side. The reason is we are not running the model in our area. The any AI we are leveraging on Google Gemini Vertex API. So any request communication is happening to the which LLM making any decision, these are all going to the Google Cloud. But the in internal all these simulators are not in Google Cloud. They are in our private cloud. So they haven't we haven't see a huge case, or maybe it's a good point we can think about it. Did we or was we able to reduce or make any difference in the power consumption? Mm, as of now, sir, no, we haven't looked into that. And that was doesn't come, like nobody brought that like we should be look into the power consumption. But yeah, there may be changes definitely. Uh, but I don't think so it will be significant, because we are running the agents, and agent just applications, but actual work is being done outside of our private network. Okay, any other question do you see in the chat, Pankaj?
No question in the chat box. I'm actually, I want to know something like you're using third party for running your programs or that Google
No,
Cloud.
we are using their API because we use the Google Cloud. We have their contract our data will be our data. It's not going out of our environment. We are using the Google LLM APIs. Yes,
Okay,
Geminis. Yeah,
okay, okay, fine.
but our all the program and agents they are running in our private cloud.
Okay, okay, okay.
Yeah. Okay, so I think uh, lesson learned and key takeaway here are the uh, like a data quality and domain expertise define success. So the whole thing which I have experienced is while I was working developing the ML models with the data quality that time. Data quality is the most crucial part in training any AI model. And knowing about the domain, what you are solving, which problem you are trying to solve, try to learn as much as possible about that the domain. Even though it's not a problem, it may be the success story about that domain. Learn about that too. So means that's learning the data and domain is a key in the any anyway it's a key in the in any AI or ML solution, but it's key for any developing any solution as well, not just AI. That's a whole thing which I have based on my experience I have seen, like this is the most important thing. Second thing is AI model amplifies, not replacing human decision making. Yes. Uh, yeah, that's a scary part right now going on in the industry. Like, is will AI replace human? I means everybody has their own opinion, but in my opinion, as long as we stay uh, continue learning and and keep like a our domain expertise is the key driver which going to be always human in need. If because if we know the business and the domain, we can ask the AI to do whatever we want. But if AI don't, if we are developing any model and it does not have the AI expertise, the domain expertise, it will not be at level as human or ever. And again, like the scalable architecture ensure real business value. So that I was talking about that earlier too. Like doing POC is great in the industry, but it's necessary. It's an initial part of learning. I would say we should do as many POCs as we can always. And but when it's come to the helping industry, then let's try to put that in the foolproof production system. And just an example, I think any means you guys know better than anybody like about there are so many research happening, but bringing those research to the industry is not as easy. It need like a lot of different type of effort to bring that or bring that to the industry solution. And yeah, means I would always say like in a EV industry, like a EV car is not new. So they are there, I think early 90s, there was EV cars there. But when they put that in production and at that scale, today EV is like a kind of in the mainstream. So that's how it is. Like developing POCs and concept is good, but putting them into the real world is the solving the real world problem is always what actually world need. Yeah, again, engineer plus data plus domain. So as was I was earlier talking, like domain means I have seen like earlier I was more focused in my and earlier career in my technical skill. Always like learn more technology, and eventually later I learned learning technology is good, but if you want to work in industry, you need to know the domain. If you know the domain, you can learn the you can apply your skill technical skills there. But if you just learn the as a technical skills, uh, people is seeing especially in the current industry in the like only technical people can be replaced, but industry still keep those people who have the domain knowledge. These are the key lessons, and my AI maturity journey was like started from a descriptive analytic, like from Excel sheet when the energy planner was using Excel sheet, and now then they start doing the prediction of the demand, then prescriptive system, then start making recommendation to the thermal power, like how much energy they need to generate or not, and then now moving to the AI automation uh, in my logistic domain. Any question? I know I went little faster.
Oh, not an issue. That's completely fine. Actually, I have one question. Like, we all mostly of us, the participants here are academicians. Like, what kind of, actually, we have students that are working on the machine learning models. Even all of us are working on the machine learning models
Mhm.
and deep learning models. Like, what kind of skill set should we incorporate in our students so that they are industry ready? Like if we have data, they are good enough
Mhm.
to implement any model. Like what additional thing we should like teach our students or guide our students, or even if any of the academician wants to go to the industry, like what kind of, how he should prepare himself or herself. So what is your like
Yeah,
advice?
it's a very good question, and right now it's everywhere in the like a industry. That's a big concern. What we should be get ready with that. So uh, I my personal I would say, because as a student and there is a different level of learning and the freedom and the enthusiasm you have when kids we are in the college, and the if we bring that all together and just if kids means and students, basically if students they would like to I would say in past my almost more than 10 year of in USA, what I have learned is we we just not uh, we should not just learn for work to get the work, basically. uh, what I have seen here, people who is learning for just try to do something. If we can foster that somehow we can foster that skill or desire to in the students, because if like technical skill, as you are saying, like they have the data, they know how to develop the model, and they are every other student, they are developing little different models based on their ability and their resource availability to them. That's important to develop the skill, uh, uh, and just try to get into solving the problem. Not no Don't learn the technology just in sake of learning the technology. So always try to solve what problem we are solving and what value it will bring. So if we have this concept, like even in the industry today, like if I go in my office and we get a project, we always first thing ask what problem we are going to solve here. That's the important part. And means things have changed so much since I was in the college, or maybe each college has a different environment as well. But I have seen like we were doing like at least I can say myself, we were just learning the technology, learning, not did not focus that time to solving the problem of industry. So just they can take any example from their current life, today life, like any big project you can see, they turn today as a big company. They start from their personal problem or their problem what they are facing on their day-to-day basis.
Right. Realistic problem. They should work on actually real problems, I think. That's the opinion.
Yes. So the mindset, the whole thing is about the mindset. If kids bring the mindset of I'm here, I'm here to solve some problem. What problem we are solving? So the mindset, bringing that mindset will change industry, will change their career definitely.
Cool. And I think from your presentation, what I got to know, like in this machine learning and artificial intelligence, most important thing is data, preparation of the data, collection and the preparation of the data. Then.
Yeah, so the two most important thing, what I would say, first thing, your data had to be clean and the relevant. Okay, and clean data means try to run through so many variation, so many cleaning cycle, and try to remove all the outliers, trying to find which are the features, means data points really matter. Then only keep them. To keep your just feeding lot of data to model and train, it doesn't mean it's I think you guys know better than us. It doesn't give the better result. It's always try to keep refining your data as much as you can. And that's the first thing. Second thing, when I was working, it's being like a 2 year, I haven't developed any machine learning model. The tuning of the model. So
Tuning of the
we
model.
train, we have trained first time when my first model was, we train almost 20 to 30 times. Because we and it training is expensive, right? But we had to do because we were learning. A whole team was learning, and we were just learning and implementing the different like a tuning and the different parameter, different settings. So because and students, I think they may not have the leverage of using low GPUs and that expensive
This is the most important
resources.
challenge that we face here in the colleges. We don't have the access to GPUs, well,
Yeah,
expensive
it's
GPUs.
everywhere. Means here in US, people had different, but I would say the because we don't have that leverage of using the high capacity resources. If we can work heavily on the cleaning the data, have only the data what we need, and just try to understand all the parameters, all the tuning things, and the algorithm the well enough, so we don't have to go repeat our things so many times.
Okay, let me give time to our participants. Even I am asking the question mostly. Any participants want to interact or want to know something, want to ask any questions? If you have any doubts, participants. Actually, we have participants from electrical background, civil background, mechanical, even computer science
Sure,
background.
sure.
So
Yeah.
I think your presentation has touched everyone. That's
No,
very
thank
nice.
you. It's a good actually. AI is and the learning about different how the different domain work is 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 good.
Okay, Mr. Sandeep, I think we don't have any questions. Still, I'll give you another 1 minute from the participants if you want to interact.
Yeah, no problem. And
Want to ask
I think
anything.
if you have any question, you can reach out to me. I will give my detail to Pankaj, my LinkedIn, and so people can reach out to me
That
anytime.
would be good.
Yeah, I forgot to put it here in presentation, but I will share my LinkedIn detail.
When I share the presentation, I'll share your LinkedIn profile as well.
Sure.
I'll share your PPT with the participants.
Okay, sounds good.
Okay. Okay, then thank you so much for your time, for giving us this time and this presentation. This is really helpful.
Yeah, I highly appreciate and all everybody time. Like I know time is most precious thing, and you guys stick with me oh, more than an hour now, and I highly
Me,
appreciate.
actually, it was really interesting. Actually, even I am feeling interesting and connected.
Yeah, sure. Thank you. Thank
Okay,
you.
thank you. Thank you so much.
Yeah.